Dear students, in this video we are going to learn about the concept of linear regression in machine learning. The objective of this video is to describe the introduction about the linear regression, example problems, common regression algorithms, linear regression concept, computing a/b values in y is equal to a plus bx, error in the simple regression, and how to interpret the intercept. Generally, classification model is a supervised learning algorithms contains two types. One is classification model, another one is a prediction model. Classification model to solve a wide variety of prediction problems where the target value is the categorical value. We will build concepts on prediction of numerical values, which is another key area of supervised learning. In prediction of numerical variables, the target value will be a numerical variable. This area, also known as regression, focusing on solving problems such as predicting value of real estate, demand forecast in retail market, weather forecasting, etc. These are all the examples for the linear regression. Example of regression. We have mentioned many times that real estate price prediction is a problem that can be solved by supervised machine learning algorithm. That is, we also call it as regression. Consider a new city is established by the government. It is the primary hub of commercial activities in the country. In the last couple of decades, with increase in globalization, commercial activities have intensified the new city. Together with that, a large number of people have come and settled in the city with a dream to achieve professional growth in their lives. As a large number of housing projects are started in every nook and corner of the city, there become a demand for the apartments, but there is no supply for the demand. To get the benefit from this boom in real estate business, one person, Karan, has started a digital market agency for buying and selling real estate. Initially, when the business was small, she used to interact with buyers and sellers personally and help them arrive at a price quote, either for selling a property or for buying a property. Her long experience made her to become more and more intuition on the correct price quote of the property. Given the value of certain standard parameters such as area of the property, location, floor, number of years since purchase, amenities available in the property, all these are all the input values given to. All these are the predictors. Based on these predictors, she used to correctly quote the price. However, with the huge surge in the business, she is facing a big challenge because she is not able to manage the personal interactions as well as setting the correct price quote for all the properties all alone. So what she has done, she hired an assistant for managing the customer interactions. But the assistant is new to the business. She is struggling with the price quotations. How this problem was solved by the Karan. Frank is a Karan's friend. He is having a depth knowledge in the machine learning models. Frank comes with a solution to Karan's problem. What he did is he built up a machine learning model that can correctly predict the values of the real estate if certain standard input parameters are given, such as area of the property, location, floor, number of years since purchase, amenities available in the property. She used this regression model to solve the current real estate price prediction problem. Like this is one example. Real estate price prediction problem is one of the good example for regression model. In the same way, a bunch of other problems can also be solved by using this regression. such as stock market prediction, weather forecasting, etc. In the context of regression, the dependent variable y is the one whose value is to be predicted. In this real estate problem, price quote of the real estate is the dependent variable y, and this variable is presumed to be functionally related to the one or more number of independent variables. They are called as predictors. In the current problem, price of the real estate is y, and predictors are area of the property, location, floor, and amenities available in the property. They are all the independent variables. They become predictors of the model. So in other words, the dependent variable depends on the independent variables or predictors. Regression is essentially finding a relationship association between the dependent variable and independent variable. So that means y is a dependent variable, x is an independent variable, y becomes the function of x. Some of the common regression algorithms are simple linear regression, multiple linear regression, polynomial regression, multivariate adaptive regressions, logistic regression, maximum likelihood estimation. So these are some of the examples of the regression algorithms. In this video, I am going to discuss in detail about the simple linear regression. As the name indicates, simple linear regression is the simplest regression model which involves only one predictor. This model assumes a linear relationship between the dependent variable and independent variable or predictor variable. So here in y is equal to a plus bx, y is a dependent variable, x is an independent variable, where a is an intercept, b is a slope. So we can show the relationship between y is equal to a plus bx. Various parameters involved in y is equal to a plus bx is shown in the diagram. Here a is the intercept and b is nothing but the slope of the linear regression line. In the context of Karen's problem, if we take the price of the property as the dependent variable and the area of the property as the independent variable, then we can write the write it in a simple linear regression form. Price of the property is equal to function of area of the property. So when we reformulate this into the regression model, so price of the property is equal to a plus b into area of the property. So where a is an intercept and b is the slope of the straight line. Here b is the slope of the line and a is the intercept of the line. The value of intercept indicates that the value of y when x is equal to 0. It is also known as intercept or y-intercept because it specifies where the straight line crosses the vertical or y-axis. So if you see this diagram, so this intercept specifies where the line crosses y or intercepts the straight line. It is known as the intercept or y-intercept because it specifies where the straight line crosses the vertical or y-axis. as we see in this diagram. So this specifies where it crosses the y-axis. Slope of the simple linear regression model. Slope of a straight line represents how much the line in the graph changes in the vertical direction over a change in the horizontal direction. That is, slope is equal to change in y divided by change in x. Here we call the change in y-axis as rise and the change in x-axis as run. So rise is represented as y2 minus y1. Run is represented as x2 minus x1. So finally the slope is represented as rise by run, that is equal to y2 minus y1 divided by x2 minus x1. So in the diagram, if you see, rise is equal to y2 minus y1, run is equal to x2 minus x1. Let us take up one example. How do we calculate the value of the slope? Consider there are 2 points, minus 3, minus 2 and 2, 2. This is x1, y1. The second one is x2, y2. So here minus 3, minus 2 is x1, y1. 2, 2 is x2, y2. So if you substitute these values in y2 minus y1 and x2 minus x1, the rise becomes 4. Run becomes 5, then slope value is equal to rise by run, that is equal to 0.8. There are 2 types of slopes in a linear regression model. One is a positive slope, another one is a negative slope. By combining these positive and negative slopes, we get different regression lines based on this slope. The first one is linear positive slope. Second, curvilinear positive slope, linear negative slope, curvilinear negative slope. Linear positive slope. If you see that linear positive slope, if you look at the graph from left to right, the values are increasing in the direction from left to right. Here, the value of rise and run, that is the delta x, y2 minus y1 is called as delta y, x2 minus x1 is called as delta x. So in the positive slope, in the linear positive slope, the delta y and delta x both will be positive. So therefore the slope is also positive. In the second scenario, the delta y is negative and delta x is also negative. So in that case also it is a positive slope only. Curvilinear positive slope. If you look into the diagram, the curve is in the increasing direction only from left to right, but it is not a straight line, it will be in a curve shape. So that is the difference between the linear and curvilinear positive slope. All the curves in the shown slide is curvilinear positive slopes only. The slope will be in the upward from left to right direction. Only the slope value varies, but they are all in the positive slope only. All the slopes are in the upward direction from left to right. Linear negative slope. If you see the linear negative slope, when you look into the diagram from left to right, the slope decreases. So it is in the downward direction. So the slope moves in the downward direction. So therefore, here if you see the value of the delta y and delta x, any one of these two parameters, delta y or delta x, may be negative. So in the first scenario, delta y is positive, delta x is negative. In the second scenario, delta y is negative, delta x is positive. So in these scenarios, the slope will be negative. So therefore, it is a linear negative slope. Curvilinear negative slope. Here also, the slope will be in the downward direction from left to right. So these are all the curvilinear negative slopes. So another type of graph that we obtain from the given inputs is, so there is a scattering of the points, there is no relation. We cannot exactly find the relation between the x and y. So it is very difficult to conclude whether x and y are dependent here or not. So this gives you a no relation graph scenario. So error in the simple regression. The regression equation model in machine learning model uses the slope intercept formula in the algorithms. X and y values are provided to the machine and it identifies the value of a and b by relating the values of x and y. However, identifying the exact match values for a and b is not always possible. There will be some error associated with the prediction. This error is called as marginal or residual error. So that is y is equal to a plus bx plus this error. This is a residual error. Let us see what is this residual error. Consider a college professor believes that if the grade for internal examination is high in a class, the grade for external exam will also be high. Consider there are 5 random student internal and external marks are given to the model. From this model, the professor wants to find out what could be the external marks of a student given the internal marks. The scatter plot was drawn to explore the relation between these internal marks and external marks. So here, internal marks are given on the x-axis, external marks are given on the y-axis. So in the relation between these internal marks and external marks are shown here, and the linear regression line is fitted. And this line, if you see into the linear regression line, it is not exactly fitting all the values in the model. It is just only cutting through the data. The line is just cutting through the data. Some of the predictions are lower than the expected. See this prediction. Some of the predictions are lower than the expected. Some of the predictions are higher than the expected. Here, all the points here are higher than the actual values. Some values are lower than the values. Some values in this are lower than these values. So when you see these values, they are all above the values predicted on the line. Some values are below the values predicted on the line. So therefore, they are not exactly fitting. So this difference in the desired value and the actual value is called as this difference between the predicted value and the actual value is called as residual value. Thus, residual value is represented with the symbol epsilon. So now the regression equation will become y is equal to a plus bx plus this epsilon, that is residual value. If you know the values of a and b, and it is easy to predict the value of y for any given x by using the above formula. But how do we calculate the value of a and b in this equation given x and y? So this is done by using the technique called ordinary least square technique. Is used to find out the values of a and b by minimizing this residual error epsilon. So our objective is to minimize the sum of these errors of the prediction and the actual values. The sum of the squares of the errors is represented as sigma I epsilon I square. So here sum of the squares of all the errors for all the points or all the data is computed. So we need to minimize this sum of the squares of the errors. So it is found that sum of the squares of the errors is least when b is taken the value. So if you substitute this expression and when b is taking this value, then it is observed that sum of the squares of the error is least. So how this b is computed? B is computed across all the points in the given data. So xi is nothing but one particular value, x bar is nothing but the mean of x, yi is one external value, external marks, and y bar is the average external marks. So the covariance of xy is computed as sigma I for all the values of I. We need to compute the product xi minus x bar, yi minus y bar. That is nothing but the covariance of xy. divided by variance of x is to be computed, that is obtained by sum of the squares of each x value subtracted with the mean of the x. That will get you the variance of the x. So once you get this b value, so when b takes this value, then the sum of the squares of the error will be least. So once you know the b value, you can obtain the value of a by substituting the value of mean x and mean y and b value. We will get the value of a here. This is how we compute the value of a and value of b from the given data set. Let us take up this internal marks and external marks of that particular table, and we will calculate the mean a b values for that. So for example, what is the mean of x? 19.93, mean of y is 56.8. Sum of the squares, that is ss, that is obtained as 226.93. Sum of the products, that is numerator, that is 429.8, that is obtained. That means we are substituting the mean values of x, mean values of y for all the x and y values, and we are calculating the numerator, that is sum of the products, sp, sum of the products, sp, sum of the, this is s, sum of the sums, that is ss, that is denominator. So both sum of the squares, sum of the products are computed, and we are getting the values like this. So we are substituting these values in the computation of b, that is b is equal to sp by ss. So after the substitution, we are getting 1.89 approximately. So from this 1.89, we will calculate a is equal to, the value of a is computed as y bar minus b into x bar. Here there is a mistake. This is y bar b into x bar. So we are computing. What is y bar? The value of y bar is 56.8. So this is y bar, 56.8. This is x bar, 19.93. So 56.8 minus, what is the value of b computed? 1.89 multiplied by this x bar is substituted. We are getting the value a as 19.04. Substituting these a b values in the linear regression, we get y is equal to, that is y is equal to, that is value of the dependent variable is equal to 1.89 into independent variable plus 19.04, that is intercept. Hence for the above example, the estimated regression equation is constructed based on the values of a and b like this, that is y is equal to, that is y is equal to So in the context of the given problem, we can say that marks in the external exam is equal to 19.04 plus 1.89 into marks in the internal examination. So that is equal to MA external marks is equal to 19.04 plus 1.89 into internal examination marks. So here the steps followed in computing all these values for AB values are: step 1, we are calculating the average x and average y, that is mean x and mean y values are computed. Next in the step 2, we are computing the product of the x mean and x y mean with respect to the x and y values. And step 3, we are computing the x mean subtracted from xi and y mean subtracted from yi. Step 4, we are computing the sum of the this xi minus x bar into yi minus y bar. Then step 5, we are computing xi minus x bar whole square. And step 6, we are calculating the total sum of the xi minus x bar whole square. Interpretation of the intercept. Here, as we have already seen, that the simple linear regression model built on the data is mx marks is equal to 19.04 plus 1.89 into internal marks. The value of the intercept from the above equation is 19.04, 19.05, 19. However, none of the internal marks are 0. So the intercept 19.05 indicates that 19.05 is the portion of the external examination marks not explained by the internal examination marks. So you can, from this diagram, we can see that the portion of the external marks 19.05 is not explained by the internal marks. Slope measures the estimated change in the average value of y as a result of the 1 unit change in the x. So here slope 1.89 tells us that the average value of the external marks increases by 1.89 for each additional 1 mark in the internal examination marks. How do we find the minimum and maximum points in the curves? The minimum and maximum points on the graph are found at the points where the slope of the curve is 0. It becomes 0 either from positive or negative value. The maximum point is the point on the curve of the graph with the highest y coordinate, and the slope of that particular y coordinate is 0. Similarly, the minimum point is the point on the curve of the graph with the lowest y coordinate, and the slope of that y coordinate is 0. Consider this example graph. Here the y coordinate maximum value is 63. So 60 is the point at the highest point in the curve. It has the greater y coordinate value than any other point on the curve. So it has a slope value of 0. Minimum point 40 is the value of y in this graph. This is the minimum point and is the lowest point on the curve. It has the lesser y coordinate value than any other point on the curve, and it has a slope value of 0. In the next video, we are going to learn about the multiple linear regression. Thank you for watching this video.